Welcome back to Newmber Math, in which we apply color to identify and sequence within math, always doing our best to provide students the opportunity to solve independently. Please feel free to subscribe to the video if you do like so. Thank you. All right, my Math 2 Semester 2 crew in the new year. Yes, kicking off quadratic functions in standard form. Also, it's a brand new unit, meaning new. Key terminology to know. Okay, parabola, a symmetrical U-shaped curve that opens upward like a smile when A is positive. We will get to the A value shortly, but let's go ahead and do our smile of a parabola. Okay, and it said when A is positive, so let's just say that A equals 1. Yes, that's a positive 1. And downward like a frown when A is negative. All right, so for those negative Nancys in the world, let's go ahead and do our frown. And this time we will set our A value equal to -1 to represent that negative A. All right, key term number 2 is the vertex. This provides our minimum or maximum point and is where the parabola changes direction. Okay, so when we have this A value and it's positive and we've done our smile over here, okay, now all the way down in the valley, all right, we will have our vertex. Now, this is also providing us our minimum point. I think that's just pretty self-explanatory, so I will not put that in, but it also changes direction when it frowns as well, and A is equal to -1. Now, if this gives us our minimum, this results in giving us our yes maximum, all right? But that is also our vertex as well. Okay, so we do have one more term to cover real quick, and let's see what that says. Oh my goodness, axis of symmetry is the x value of the vertex. Okay, so whoa, our point here is going to give us some coordinates, and the axis of symmetry is the x value of that vertex and is the line of symmetry. Whoa, and you're telling me that line of symmetry, well, if things are symmetrical, they're perfectly even on each side. All right, so our line of symmetry, and since it's crossing that x-axis, will run vertically. Wonderful. Work. So that means every point on each side of the parabola will be at the same spot, kind of like it's mirroring itself. All right, so if I had a point here, there'd be a point here. If I had a point here, there'd be a point here. And if I had one there, there'd be one there as well. And same for the other. Yes. Okay, so I will try to do this as efficiently and effectively as I can for your best understanding, okay? Now, taking a look, all right, I color-coded it for us in standard form, okay? So y equals, all right, ax squared. Your a is the coefficient of x squared, all right, plus bx. Now, this can also be a negative as well, but it's the coefficient of x is our b, and the plus c, which also can be a negative well if that were like -15. That's just a constant, and again, just a number that stands by itself. All right, now I did write these on how you will see them on a quiz or like a standardized test. All right, so we know it's y equals, okay, but f of x, okay, is equal to y, and y is equal to f of x. They're all the same, as Richards is Newmber, and Newmber is Richards. All right, so here we go. F of x equals x squared plus 4x minus 5. The first thing we will do when working with these, just identify, let's get comfortable in locating our A, our B, and our C. Okay, so it's looking for the coefficient of x squared. Well, oh my goodness, why isn't there a number in front of x squared? Is it 0? No, there's an imaginary 1 right in front of that x squared. All right, so our A equals 1. Now, this is going to tell us something that's down here as well. Does a parabola open up like a smile or down like a frown? Well, it's down like a frown if our A is negative, but our A is, yes, ultra positive. So that means it will open up. And I'm just going to go ahead and circle that. And I just wanted to show you briefly for your own understanding. Okay, now our B value, whoa, let's take a look. Plus 4x, because it's a positive 4 in front of the x. All right, the coefficient of x is just 4, and that's a positive 4. Wonderful. And leaving our constant, which is our c value, well, let's take a look. Whoa, plus c, this time, because it's minus 5, we will just put negative 5, because again, when we are reading these, we go from left to right. All right, here we go, negative 5 to stay alive. Wonderful. Now, I just want to go ahead and do the exact same for the next one as we move forward, but this one's going to be in black and white. And as I go through it, I just want you to start thinking about these things, okay? All right, now when we're looking for, we have f of x equals negative x squared plus 6x minus 5. All right, well, what does our a equal? All right, well, there's just a negative in front of that x squared. Yes, great call, wonderful job. I will put it in as negative 1. I think someone had already said it. Whoa, I know we're working a remote, but yes, I can hear that slight subtle sound. Okay, so our parabola will open up or open down. Well, it's negative, it's going to open down. It's going down. All right, we might actually just want to put that, well, a equals negative 1, and we'll do the same over here where a equals 1. Okay, so for our first batch today is this intro. A is just going to be negative 1 or positive 1, and we'll discuss further as we go, but this is just an intro, but it does cover quite a bit. All right, so now our b value, all right, is the coefficient of x. And what's the coefficient of x here in this case? Yes, wonderful job. I will put that down as well. And our constant, yes, negative 5. Thank you. It does stand alone. Wonderful work so far. All right, but what if I'm asked, what is the y-intercept of the function? Great news. The y-intercept is simply c. All right, now, if we remember that f of x is y and y is f of x, when we are working with functions, this means we're working with an input, which is x, and an output, which is y. So when we input 0 for x, all that's going to be left is c. And I did this down below here just to give you an example, okay? So y-intercept equals 0, c when x equals 0. That's a big kicker there, okay? When x equals 0, all right, the y-intercept equals 0c. So just to take a look at that and how that actually functions, well, oh my goodness, how that functions, yes, we're given a function. We are inputting 0 for x. That's all we're simply doing, and that's what I did. I did right here, okay? I just put in 0 every time we see that x. Now, when we enter this into our calculator, we need to get comfortable in putting those parentheses as well. So that's why I wrote them, and we will have to write them out to find the y within our vertex. Yes! Okay, so 0 squared is 0 times 0, giving us, yes, 0. Plus 4 times 0 is 0. Oh, minus 5. Now I see why it's like that. Because every time we multiply something with 0, because of our coefficient and our x value is 0, it just leaves us the c, because c is not multiplied by an x. Wonderful work. So we will simply write our y-intercept then as 0, comma, negative 5. And yes, I put it in green. No, you do not have to. As for this next one, I will not do in color, okay? However, take a look. It is the exact same. Wonderful recognition. And yes, I did put that for you again. So you will see that as a quiz question. It's going to ask you, what is the y-intercept of the function? All right, so we'll be given a function just like this or like this, and we will just have to write the y-intercept just like we did. But remember, the y-intercept is 0, negative 5 when x equals 0. And when we write coordinates, it always goes x, y. All right, so just a little bit of a refresher there. Okay, to find the vertex, we must find the axis of symmetry. We use this formula below, and we simply apply what we have identified. All right, and taking a look at our formula, x equals opposite of b over 2 times a. And I say the opposite of b for a reason, okay? Let's take a look at this. We are going to write it out. I'm going to take the long way home with this just to show you, okay? So when it has that negative in front of that b, well, that means we're just going to simply have a -1. And that -1 is going to be multiplied by our b value, which is, yes, 4. Thank you. Let me actually put the x equals out front. We will set that over the number 2 times our a value. Well, what's that imaginary number in front of our x squared? Great job. All right, so now if we do the math here, well, -1 times 4 is -4. We set that over 2 times 1, which is 2. I know, seems so basic, right? But then again, that's all math is. Identify, recognize, and sequence. Equals -4 divided by 2, which is -2. All right, we have found the first half of our vertex here. Okay, let's go ahead and try this other one together, and let's see what it looks like. Oh my goodness. Well, actually, I did want to show you. I didn't want to take this long way home. This is just to show you why we take the opposite of b, because if our b value is 4 and we multiply by negative, well, that 4 just turns into -4. All right, so if we just take the opposite of our b, what's our b value here? Well, let's take a look. We have the a equals, the b equals, and the c equals. We've already identified it. Our b is 6. What is the opposite of b? Exactly, it's -6. So x equals -6. All right, now we'll just do a little bit of mental math. 2 times a. Well, we'll do 2 times what number? -1. 2 times -1 is, yes, -2. Equals -6 divided by -2 equals 3. Wonderful work so far. All right, moving forward, we just found the x value of our vertex. Now let's find the y value by plugging in our x value. All right, well, here's what we need to do. All right, I'm just going to go ahead and plug in our new x value, because we know that x equals now -2. We're just going to plug it into the function, but remember, all right, we don't need to put the +1 there, because when we multiply by a +1, the number stays the same. But what I do want you to do every time when you do this, when we take our x value of -2, I want you to set it in parentheses. All right, so here's our x. We're going to put it in parentheses. We do know that -2 is x. We need to square that. All right, we'll do our plus. Put your 4 down. All right, again, in parentheses, put your -2. Finish that off by writing -5. All right, we will simply put that into our calculator. Now, because of the parentheses, when you do put this into your calculator, it will give you a +4 here. All right, so -2 squared is 4. Then if we do 4 times -2, we get -8. -5 equals, well, 4 minus 8 is -4. All right, minus another 5 is -9. So our vertex now, actually, let me put that in orange, is -2, -9. All right, so the first thing we do is find that axis of symmetry, which is the x value of the vertex. All right, we simply use this formula. Once we find that, we just plug it into the function. All right, I'll pull in the calculator just so we can actually see how that functions. Well, let's open that parenthesis. All right, let's put in our -2 and close that parenthesis. Hit x squared over here to square it. All right, we'll do +4. Open another parenthesis, put in another -2, close it, -5. Hit enter. What do we get? -9. So the exact same answer. All right, this was just figuring it out and just showing you each step of the way, but simply just plug it in. Now, there is another way we can use that in our calculator. We can actually hit y equals, and I will go over it real quick. I know I said I'd use Desmos later, but just real brief. If we just plug in the function of x squared, so you will actually have to hit to the right of the alpha in green, where it has the x and the theta. Go ahead and hit that. Then we will hit the x squared button again to make sure we square it. All right, we're just plugging in our function. So plus 4x minus 5 we will put to finish it. Plus 4. And again, that x is coming to the right of alpha. Minus 5. If we hit graph next, followed by trace, and then we plug in our axis of symmetry or our x value of -2. So -2. Hit enter. What does it say y equals? -9. So you can do it two ways in the calculator. All right, I will save Desmos for class just because it's a super shortcut for all of these. And good news is the SAT permits Desmos, so please feel free. All right, so x equals the opposite of b over 2 divided by a. We did already solve for our axis of symmetry, our x value. Now we do need to find the y. How should I write that? Well, let's take a look. We actually do need to put the -1 because things change when we multiply by a negative. All right, so we will put, let me get that back in black. Back in black. All right, now let's plug it in. Now our x value this time is 3. I will have to put that in parentheses and I will have to square it. All right, plus 6, open a parentheses, 3, close it, minus 5 equals. All right, now this time around, we don't have to. We can just go straight into, how do you guys want to do it? Yes, let's put -1, open a parenthesis, put in 3, close the parenthesis, hit x squared to square it, plus 6, open a parenthesis, 3, close it, minus 5 equals 4. All right, so your vertex here is 3, 4. Because we found our x value of that vertex, we then plugged it into our function and found the y value of 4. All right, you do have 2 to practice independently to go through these. And then, if you're confident, what I would do is I would just go search online for some different problems and then test what you know. Take the info that you do have and practice yourself. I mean, practice builds proficiency. All right, I will go over the answer key in 3, 2, 1. And to go over your 2 practice problems, f of x equals -x squared plus 9x minus 20. We do have a negative in front of the x squared, so a -1 is our acting coefficient for our a value. Okay, the b is the coefficient of x, which is 9 in this case, and c is the constant of -20. Great job. Our parabola opens up or down. You guys had said down like a frown because of that negative a value. Great job. Now the y-intercept again is just 0, -20, because when x equals 0, all that we will have left is -20. So that will always be our y-intercept, taking that route. And then for our vertex, I'll zoom in a little bit here. All right, x equals opposite of b over 2 times a. Again, I took the long route just to show you that negative there is at -1 times our b value. All right, so -1 times 9 gave us -9. We put that over 2 times a. All right, well, it's 2 times our -1, which gave us -2, which equals a positive 4.5, as the same rules apply when you divide just like when you multiply. Yeah, I'm kind of a dork there. All right, anywho, again, plug in. We do have that -1 acting as that coefficient of x squared, so we do have to put it there, okay? Then open a parenthesis, drop in our 4.5 that we now know what x is, close it, square it, plus 9, open parenthesis, 4.5, close, minus 20 equals 0.25, giving us a vertex of 4.5, 0.25. All right, and going back and trying practice 2, we were given, let's work it in larger, x squared plus 8x plus 15. Now our a equals 1, that imaginary 1 there in front of x. Our b is the coefficient of x, which is 8. Wonderful job. Your c is your constant. Guys, great work. Plus 15 or just 15. We don't need to put the negative. All right, now our parabola opens up. And why does it open up? Yes, our a value is positive. Great job. Y-intercept is 0 and yes, 15. Excellent work again, guys. All right, for our vertex here, first we need to find that x value or that axis of symmetry. All right, so we will take the opposite of our b, and just so we can zoom in, if our b equals 8, we can simply just take the opposite. So we drop a -8 there, and then we put it over 2 times our a value. Well, 2 times 1 is 2. So -8 divided by 2 equals, woo, little yawn there, -4. All right, we have found our x value of our vertex. Then we just plug in -4. Anywhere we see x, make sure to wrap it in parentheses. All right, so we had x squared, so we did -4 squared with that x wrapped in parentheses, plus 8 times, again, -4 wrapped in parentheses, plus 15 equals -1, giving us a vertex of -4 and -1. And that wraps up today's lesson. Let's continue to crush and enjoy that day tomorrow, even though it's going to be below 0.